Good afternoon, learners. My name is Mr. Owen, facilitator for mathematics N1, and today I want us to continue with our module for algebraic graphs. Right, the main objectives that I want us to achieve today. Number one, I want every learner by the end of this lesson to be able to find gradient and y-intercept of a straight line graph. Right, last time we were looking at a situation whereby we are required to draw a straight line graph. Now the graph is drawn for you, but how do you find the gradient and how do you find the y-intercept? That's the first objective. Then secondly, we want to look at a new type of graph in this module called the hyperbolic graphs. I'll explain this one, then we work out some examples. Right, so as we start, I want us now to look at our objective number one in the form of questions so that we understand. So let me put down the questions that you are going to answer as we explain how gradient and y-intercept is found. Right, we have got a graph. This is your x-axis, this is your y-axis, then that is the graph. Right, we are told that at some point there is a 3, and at this point there is also 3. Right, then you can have a 1 there, a 2, at that point, a 1 and a 2. Right, then we also need another graph in this form. The line is going down like that. Right, we have got 4 there, then we have got 2 there. This is y-axis, this is x-axis. So we want to find gradient and y-intercept. Right, now let's look at question 1. Right, so this graph has been drawn for us and we know it is always of the form y equal to mx plus c, where the c is the intercept and you want to find that m. So we need to know that if you are finding m, there is a formula which says m is equal to, you can say y2 minus y1 over x2 minus x1. Right, some books will rather say increase in y over increase in x. Right, it's the same thing. Right, now we need 2 points now on this line. So obviously the first point is 3, 3. Remember, we always start by writing our x followed by our y. Right, then the other point we are going to take will be the origin, because this is the only point that you can determine given by 0, 0. And this is going to be x1 and y1. Right, having those 2 points, we can now come and substitute on the formula, which will then become 3, which is that 3 there, minus 0 for that y1 over, we come back and take 3 minus a 0. Right, this will then become 3 over 3, which is equal to a 1. So the gradient of this graph is 1. Right, now the y-intercept is called C. Right, C is the point where the line cuts the y-axis. So because it is cutting at a clear point, we can see that it is cutting at 0. So our C, it is 0 there because that is part of our coordinates that we took. Right, so that's how we find the gradient and that's how we find C. Which means if the question had asked for an equation, we're simply going to say y is equal to 1x plus 0, which is simply y is equal to x. Right, we'll be now having the equation of the line. Right, then let's look at question given 2. Right, we want to find the gradient and the y-intercept of this graph. Right, again, we've got 2 points clearly marked. Right, so here we are given y as 2, then it means our x is 0 because it is along the y-axis. Then here x is 4, then y is 0 because it's along the x-axis. With those 2 points, we can then come and say y is equal to, m is equal to y2 minus y1 over x2 minus x1. Right. You label whichever point as you desire to make it your y2, x2. So I'll choose this one, x2, y2, then x1, y1. It doesn't matter which point you choose, the answer will remain the same. So in that case, our y2 is 0, minus y1 is 2, over x2 is 4, minus y1 is x1 is 0. This will then become, if you say 0 minus 2, get minus 2 over 4 minus 0, get 4, which is equal to minus 1 over 2. So this is the gradient of the graph. And it's negative because it's going downhill. Then see, again in this case, we can see where the graph is cutting the y-axis, it's labeled as 2. So it means our y-intercept is equal to 2. Right, so that's how we find the gradient and the y-intercept of any given line. So now I want us to look at another example where we are not given a y-intercept direct, but we are required to find it so that you appreciate all different forms of questions that you meet in the exam. Right, so let's say we've got this graph x, then y. Right, the line is like that, but at this point, we know that our x is 6 and our y at that point is 4. Then we've got a point there where our x is minus 2 and our y is 2. Right, like that. But we are not given the point where that line cuts the axis. So I want to find the gradient as well as the intercept of that graph. Right. So this is how we go about it. The formula doesn't change, but we need, of course, to put our coordinates just to make sure that you do not make mistakes. Right, so this one is 6, 4. Remember, I said you always start by writing the x-axis. Right, so y2 minus y1 over x2 minus x1. Right, this will be equal to, right, if you choose this to be x2, automatically this becomes y2. This will be x1, this will be y1. Right, so our y2 is a 4 minus y1 is a 2 over x2 is a 6 minus our x1 is a minus 2. Right, the minus that we have here is for the formula, then the minus 2 is a coordinate. This becomes 4 minus 2, we get 2 over 6 minus minus 2, it becomes 8 because a negative followed by a negative, we get a positive. So this becomes 1 over 4. That is the gradient of that line. Now, how do we find the y-intercept of that graph? Right. We know that equation of a straight line has a general form y equal to mx plus c. Right. So knowing that is very important, which is what we were focusing on last time. So now we can come and say the equation of that line, even if you don't know it, it is y equal to mx plus c. And you can safely say it is equal to 1 over 4x plus C. Why? Because we now know the gradient is 1 over 4. Right, what we know is that when the line crosses the y-axis, it means our x is going to be 0 because it is along the axis. Therefore, we can now come and say we have y is equal to 1 over 4. Then we have got our x, I said it will be 0. Then we are going to have a c. In other words, y will be equal to a c. Right, so it means the value of c that you want at this point, it is the value that will be equal to the value of y. Right, now you remember very well that we said also if you want the equation of a line y2 minus y1 over x2 minus x1, we can simply say it is the same as x2 minus x1 is equal to y2 minus y1. Right. Where the x2 and the y2, they are the axis. So in other words, we can write it as m, then we have x minus x1 equal to y minus y1. Right, y1, x1, we already have them. M we also have. So we can come and say 1 over 4x minus, but what was x1? It's minus 2. Then y, what is y1? It's 2. Right. So when we simplify here, we will then have 1 over 4. Right. Because we know that at a point when we are looking for this y, x will be 0. We can simply come here and say 0 plus 2 being equal to y minus 2. Right. In this case, quarter times 2, we are going to have a half. Right. My space now is running smaller and smaller. Right. But I hope you are following what we are trying to achieve from that equation of gradient. Right, so from there, if I am to take it here, we have 1 over 4 times 2 is equal to y minus 2. Right, or y is equal to, if I multiply here, I get a 2, which is like I've got half. Right, this one coming this side, it becomes a plus 2. So in other words, y will be equal to 2 plus half. We get 2 and half. Or we can simply say it's 5 over 2. Right, so this value means is this point. Because we said this y and that c, they will be equal from what we did here to prove. So basically, this is how we find equation of a line and then substitute to find the gradient and the y-intercept. Right. I hope we are together on that part. Now moving on to the last part of our lesson, we want to look at what we call hyperbolic graphs. Right. We want to look at what we call a hyperbolic graph. Remember, the objective said you should be able to draw a hyperbolic graph. So I'll quickly explain what a hyperbolic graph is and throw a question that will answer, that will help us to understand these types of graphs. They are very much examinable, and I expect each of us to be able to draw such a graph, because you find it in almost every maths paper. Right. That has been said. Right, let's look at hyperbolic graphs. Right, these are graphs of the form xy is equal to c, where this c is a constant. Right. We know what a constant is. It's simply a number. Right. Any number, we call it a constant. So any graph that you have got that form, right, is a hyperbolic graph. Right. Now, to draw such graphs, remember, when we started this module, we said you always construct a table of values. That still remains. We need a table of values. So it means now if I'm to give you a question, right, a typical examination question would say, draw the graph of function xy is equal to 2 for x values minus 2 to 2. Right. So by the time you finish answering this question, you should be able to now view what a hyperbolic graph is. Right. So the graph is xy is equal to 2. But the values of x for that graph should start from minus 2 and end at 2. So this is how we draw the graph. I'll write solution here so that we start answering that question. Right. Please note, no one has said you should construct a table, but there is no way you are going to draw that graph without a table of values. Right. So now we have got our graph xy equal to 2, which means we automatically have a table of values with minus 2, minus 1, 0, 1, 2. Right. Now, the task is to complete that table. We need to complete that table so that we are able to draw the graph. Now, when x is minus 2, it means minus 2y is equal to 2. Right. If I divide by minus 2, I will then get y being equal to minus 1. I come and put minus 1. Then we move on and say, if we have got x as minus 1, I put minus 1 there, I have minus 1y is equal to 2. I divide by minus 1, then I divide by minus 1, I get y being equal to minus 2. So here I put minus 2. Right. Then similarly, if you have got x being 0, I have got 0, y is equal to 2. Right. In this case now, you find out that you get 0 is equal to 2, which is not correct. Right. We will explain that. Right. We'll put a question mark at that point. Then we come to this other case where x is 1, 1y is equal to 2. Then what it means here is that y is actually equal to 2. So it's a 2. Then x being a 2, we have got a 2 multiplied by y being equal to a 2. Right. What it then means here is that y is equal to, we divide here by 2, we divide by 2, then we get our answer as a 1. Then we've got a 1. Right. So now we've got that table. Then we want to draw the graph because the question said draw the graph. Right. So what you are going to note is that when x is 0, y has no value, it means there is some discontinuity there at that point. Right. I know it won't come out nicely here. Why? Because I don't have a graph paper. But for you guys there, with graph papers, you should produce a much nicer graph than what I'm going to produce here. Right. X, then y. Right, our table for x starts from as far as -2, -1, then 0, 1, then 2 somewhere there. Right, I'm just estimating, but they should be equal divisions. Then y starts from -1, -1 can be there, then you can have a 1, then you have got a 2, oh, we actually have another -2. Right, now we want to mark the points when x is -2, y is -1. Right, you just go -2, -1. You move your fingers where they meet, you mark. Right, like I said, in my case now, it won't be really exactly at the point, but just want you to understand what should happen. Then when x is -1, y is -2. Right, x is -1, y -2. Your finger there, move where they meet. Right, so in my case, they meet somewhere here. Right, then we've got another scenario where x is 1, y is 2, x is 1, y is 2. Let's say somewhere there. Then we've got x2, y is 1. Let's say it's somewhere there. Right, so the graph that you are going to produce here, something like that. Then here, something like that. Right, they are mirror images of each other, these graphs. But you should note that even if you put as many values, they will never touch the axis. And that is called an asymptote. But at your level, you need not worry. You just need to know how to sketch a hyperbolic graph. So basically, that's how we draw hyperbolic graphs. So when we meet next time, I would want us to look at past exam questions on straight line graphs and hyperbolic graphs as part of revision. Until we meet again, goodbye.